It's time to have our second session. I'll show my screen too. All right. So far, any questions about my demonstration using the OLS methods? If those of you are not that familiar with Excel, you can, just go back home and do the practicing. Okay. All right. And again, I'm saying that as long as we use the computer work, especially in this class, we use eViews. Okay, so all the computer work, all these numbers, we all from computer eViews. Okay, and as long as you understand the reasoning behind the OLS, I think that's enough. All right. So any questions so far? So if you don't have it, let's continue our our uh, our work. Okay. And actually, this is what we have it here. And I just work up to uh these points. Okay. And I really didn't calculate the x y hat. Okay, you can do it. Okay, and okay, after you have the y hat, then you can have the residual. If you want to have the y hat, how do we do that? How do we get a y hat? I need to use those numbers. Okay, and you need to plug all these x numbers in order to have the y hat. So this beta 0, so I can use this one here. So I just say this is y hat. So this y hat. Okay. And how do I have this one? Is equal to what's 103.4. So I'm just using minus 6.377. Okay. Okay. Multiply it the x. So which is B2. B2. But I have to use Y, right? So which is C2. C2 minus this. Okay? This is Y hat. Okay? Is this the same as what I did here? Oh, I'm sorry. This is just Y hat. Okay? So I don't have to do the C2 here. This is for residual. I'm sorry. Sorry. Okay. Is this the same as what I have here? Hi. No, it's not right. Oh, is this plus? Oh, this plus is not minus. I'm sorry. Huh? Where is it? I'll put it here. Did it? Okay, enter it. All right. Is this the same as what I have? Yes. Okay, then the last one is the residual. Okay, so residual is equal to actual y, which is C2, minus what I have on H2. Okay, so is this the same what I have? Okay, this is the residual, right? This is the residual. Okay, and I add all this residual. Then we say that we have positive residual and also negative residual. Sum them together, you know, is close to zero. Well, because, you know, in the computers, we also have many, many decimal places. So with sometimes all these numbers will turn out to not exactly zero, but, you know, close enough. All right. Okay. All right. Then let me put this one here. Okay. So this is what I have for 2.1. So this is estimating single independent variable models with OLS, means with just one X variable. Okay? Any questions? No. All right. Yes. Well, this is what I'm saying that, you know, from this one, there's just only put one decimal places, right? There's just only one decimal place. Usually in the computer work, usually they have 16 or even, you know, 32 decimal places. So if I'm using this one, and to calculate this one, I should have some rounding arrows. You know, not exactly right. Therefore, you know, just for practicing, you can use in either 103.4 or 103 point something, you know, no matter what, how many decimal places you like to use. Okay? All right. Any questions? All right. If you don't have any questions, then this is our 2.1, estimating the single independent variables model with OLS. Okay? Let me continue to my second section, which is estimating the multivariate regression model with OLS. Okay, I just described one is using X. Now I have many X, many X. So we call it multiple regression model, or we say multivariate. I don't like to use the multivariate, but actually in our books, the author used the multivariate. Usually we use multiple, okay? And so again, you know, with the ordinary least squares, now we are dealing with the equation, something like this one. I have kx variable. This is the population model, and I want to estimate beta 0 hat, beta 1, beta 2, beta k. So we wanted to obtain beta 0 hat and up to the beta K hat. And in order, this one is minimized. So the idea is the same. We just extend it from one X variables to many X variables, K variables. Okay? Then, would you like to see the formulas? So everybody look at on our textbook, page 61, at the bottom, footnote number 4. Did you see the formulas? Do you like to see that kind of formulas? No, I never want to see that kind of formulas in my life. And this is just two variables only, two X variable, two. If you have K is greater than 3, then how complicated it is. That's why, I'm saying that just using one variables, then we show once for all. Okay. If you have more than 2X variables, just, let it go. We just let the computer do all the work. Even don't mention about any math. Okay, so if you don't understand math, no problem with this class. So don't worry about it, okay? All right. In this class, the most important things is the application. So you need to learn how to interpret the result instead of just understand those math. Okay? Okay, so we are not going to talk about this formulas again. Okay, but you need to understand the meaning of this multivariate regression coefficient. So how do we explain all this slope? This is all co-slopes. We do have several k-slopes, one intercept, and intercept is just only one, but the slope will go with the number of X variables. Okay, so listen carefully. How do you explain those coefficient, those slope? And we call this one is called partial coefficient. Since I have many X, so this is what we call partial coefficient, and which indicates the change in the dependent variable associate one unit measurement increase in the independent variable sk in equation. This one holding. Let me this one. Just put it. Okay. Remember this word is important. Holding constant the other independent variable in the equation. So if I'm talking about the beta k, what are the other independent variables? Is from x1 to sk in equation. Okay? I think is if we don't use the examples, is really a hard time to get the idea. Okay? That's using some examples. Okay, this is an example. Let's see. I have, how many variables do I have? I have two variables. X, one is called PT, the other one, P, the other one is called YD. Okay, so dependent variable, CB, is the per capita consumption of beef in year T. So I put the T here, in year T, in pounds per person. Okay, then P is the price of beef in year T in cents per pound. Nowadays, there's No other things is in cents, right? This is so cheap. YD is what we call per capita disposable income in year T, and that's in terms of $1,000. This is what we call measurement units. Okay, so the YD, disposable income, is in $1,000. That's measurement units is in $1,000. And this P, the price, the measurement units is in cents. Okay, all right. Then how do you explain? Okay, let's thinking about the relationship first before we explain the meaning of the coefficient. So this is the consumption of the beef. Y is the consumption of the beef. And P is the price of the beef. Okay? And according to economic theory, the consumption of the beef, the relationship of the consumption beef and the price, what is the relationship between these two? I mean, the positive or negative? And so when price goes up, then the consumption of beef will decrease, right? When price go up, then the demand will decrease. So this is what we call demand law in economics. Price go up, then the demand decrease. So in fact, this is follow the expectation we have. Yes. Are you talking about this one? YD. Yeah. I'm just talking about this is first, the price first. And this is according to the demand law. So it should be negative relationship. And this is what we say income effect. According to income effect in economics, if you have the personal disposable income increase, means you can buy more beef. So the demand will go up. So the relationship between the disposable income with the demand of beef is positive. So this also follow our expectation. What I'm trying to say here is, most of us, especially for the beginners, I mean, the beginning researchers. So like all of you, in graduate school, you'll learn how to do the research work, right? Then usually, if we have the data and we just, really hurry and jump into the computer and, we hope this result coming out. Then after we have the result and we thought our job is finished. No, that is not the right attitude. Okay? Usually in economics, okay, when we do all these regressions, we wanted to see the relationship between X variables and the Y. And most of them, we have some basic economic theory behind as our foundation. Okay? So before we run the regression, we do have some expectation according to the economic theory. Okay? So we will expect the coefficient of the P will be negative, and the coefficient of the YT should be positive. As long as we get the same result as what we expectation, then maybe it's fine. But many times, you'll get the opposite result. Okay? Then in this case, you need to to figure out, you need to figure out what's wrong with it. And always put the theory behind as the foundation. So, learn in business area, learning the relationship between these X and Y variables, especially in regression analysis, or in the future, if you are working with your thesis, you do have some expectation between the relationship of X and Y. Okay? So this is how we talking about the evaluating how good of the estimation in this chapter and also in this book too. Okay? So according to the economic theory, the result for the equation 2.7 actually follow our expectation. Okay? So after you make sure that all the results follow our expectations, then you can start explaining the meaning of the coefficient. Okay, so how do we explain negative 0.88 in multivariate regression, in multiple regression? And how do you explain 11.9 for the relationship between YD and the consumption of the beef? Okay, let's learn it, how to explain it. Okay, so see this one carefully. Okay, and so the beef consumption will decrease by 0.88 pounds, since the measurement units of CB is in pounds. Consumption of the beef in pounds, right? So the beef consumption will decrease by 0.88 pounds per person if the price of beef goes up by 1 cent, since the measurement of the beef is in cents. Okay, then if this is a multivariate regression model, you have to add one more sentence, which saying in this example, the holding constant, the per capita disposal income means holding constant of the YD. Okay? All right? And again, the beef consumption will increase by 11.9 pounds per person if per capita disposal income goes up by 1,000, because the YD is measured in $1,000. Then holding constant, the price of beef. Okay, be careful. This is very important. Everybody has to understand how to interpret those meanings. So next week, if you do the presentation, you have to say something like this one. In our homework, actually, it is a multiple regression. It's not just single regression. It's a multiple regression. Okay? Okay? All right. So do you agree with this estimated coefficient has the sign that economic theory would predict? Yes, right? If the units of disposable income change from $1,000 to dollars, would the estimated coefficient change? Anybody want to answer these questions? I think I explained this one last week as our example, right? I think I asked all of you go back home and thinking about it, right? And this example, we will have this same problems. Does anybody want to answer it? I mean, the disposal income here is 11.9, the coefficient, right? And this is the measurement is in $1,000. But my question now is, if the units of disposable income change from $1,000 to dollars, then would the estimate coefficient change? I mean, would 11.9 change? If yes, then change to what? What numbers? Hmm? Uh, so, so what do you answer?
Saying that the 11.
Now is, okay, then let me go back to my equation, okay? When YD is in thousands, the coefficient 11.9, and now change to dollars, then how does 11.9 change? 100, 190, 190, 19. You mean 119? Any other answer? Divided by 1,000, because I changed from thousand to dollars. So before, if I put the 1, right? My original data 1 means what? 1,000. So I change the measurement units. The 1 becomes to 1,000. Therefore, I need to divide it by coefficient for 1,000. Well, we can do some practicing at our second example, okay? So here, understand what I'm saying here? This is about a little bit math. Okay. If yes, how would the estimate coefficient change? Change from 11.9 to 0.0119 divided by 1,000 instead of multiply by 1,000. Since the original data is from 1 to 1,000, right? So my coefficient will divide it by 1,000. Therefore, this one. Okay? All right? Okay. Now, let's look at another example. And this example, we do have data, okay? So would you like to have the data from our file, which is called FINAID in chapter 2? I mean, our data set. Okay, let me have my data set. Chapter 2. So I just get eViews first, okay? I just get eViews. So I like to have this data set. Do you see that? FINAID2. Okay, download that data. Okay, please download that data. So I'll have this data on. All right. So I have this one. And this is my, okay, let me turn on my, so this is the example, which is on our textbook. Okay, on page 61. Okay. The Y variable is financial aid in dollars. Remember, when you see the data, the measurement units is very important. Okay, always make sure to check what is the measurement units. So this financial aid is in dollars. These are Y variables. And according to the theory, the financial aid will depends on two variables. Okay. One is here we say parents. And what's the definition of parents? The amount in dollars that parents are judged able to contribute to the students. Okay, means that your parents is able to pay the tuition for you. Okay, all right. And the second independent variable is called GPA rank in high school, means the students' learning performance. Okay, and this is using GPA means, what is GPA? Usually this is called accumulate average points, for in here, maybe in the high school, three or 4 years in high schools, and you get the average score. Okay, and they will rank it, and so that's from 100, from 0 to 100, and the smallest means the low performance. If it is close to 100 means high performance. So how do you think the relationship between this? The financial aid is the financial aid that students can get it. Okay, so if your parents can pay more, okay, then what's the financial aid? Here is not just look at your own learning performance. You also consider your economic. Also, we say economic status of in just from your family. Okay, so if your parents are willing to pay more, then you can have the financial aid less. Then you will carry this financial aid. Your burden is less after you graduate, right? Okay, but your parents is not able to pay the tuition for you, then you can get more financial aid. But in other words, in the future, after you graduate, then you need to pay back more. Okay, so in this situation, I think this is just by common sense that your parents can pay more, the financial aid will get less. So which is, we say, negative relationship. Okay, and positive relationship means that if you have better performance, then I think the government or the universities are willing to give you more financial aid to support you or to help you to have your academic learnings, right? Okay, so this is positive relationship. That's why we're saying that whenever you do this research, before you collect all this data, okay, you need to have some expectation before you do the estimation. So you need to think about, if I have the beta 1 hat, according to the common sense, I should get the negative number of beta 1 hat. And this one means that I will get positive relationship between the student's performance and the financial aid. So beta 2 hat should be positive. Okay? All right. So you all download this data. So let's do the work. Okay? Let's see. So I have the data here is eViews, And this is my financial y variables and x variables. And they do have other, variables called male, but we don't use that so far. Okay, so if we do this one and we say that we have to hit the y variable first, use the control key, okay? Hit the y variable first, then x variable. So I'll follow the sequence of our equation, okay? I'll do this one first, then parents, then high school rank, okay? I highlighted these three, then I use my right click and I open as an equation, okay? So I have y variable and 2x variable in the order of parents first, then HS rank. And I'm using ordinary least square. So I'm working with multiple regression now. All right? Okay. So this is the result we have. So after you see this result, first look at the sign, whether the sign match our expectation. Do we expect the negative relationship with the parents? Yes. And positive relationship with the high school performance? Yes, we do. And this is C is called intercept or constant. All right. Anybody want to explain the meaning of these two coefficients? Or let me name one. Okay. Thinking about first. Okay, how to interpret negative 0.3. We just use 2 decimal places. That'll be fine. Okay, negative 0.36 or positive 87.38. Anybody? How about Stephanie? First one. Yeah, -1. Yeah, okay.
For the minus 0.356, it means that yeah, if their parents for every dollar increase for the parents' ability to pay, then the financial aid grant will fall. Will decrease 0.36.
And actually, we're not really worried about just $1, right? So actually, you can say that if the parents are willing to pay $1,000, although our original data is dollars, right? If the parents are willing to pay $1,000 more, then the financial aids will decrease $356. That's all. That's all. Remember, holding the student's high school performance variable as a constant. If you don't say so, then it is wrong. Remember that? That's the difference between simple independent variable and multiple independent variable. Simple independent variable, single is just only one x. So there's no other variables. Therefore, we didn't say anything about that. But for multiple regressions, since we have more than one variables. Nowadays, we have two. So if you explain the parents variables, the coefficient of parents variables, you need to holding the other variable, HS rank, as a constant. Understand what I'm saying here? Okay. Then, second one, about the high school rank. Anybody want to say something about it? Is Harry here today? Huh? You don't want to try? Okay, excuse me. Then, you know, I don't. I think I have. I did pencil. So Harry is here, right? Is Son here? Where is he? Junkai. Okay. Sonia. Okay. Then how about Junkai? Explain the coefficient of high school rank.
I think so. GPA goes up 1, and then the financial aid also increase 87.378. Human unit. And
It's from 0 to 100.
0 to
So if we make it as a like percentage, okay, if it is 11, that means 11%, right? Because it is from 0 to 100, right? So we can think about is the percentage. Okay. So say it again.
so GPA goes up 1, and then the financial aid 1%, sorry. 1%, and then financial aid increase 87.378. Yes.
What's the measurement units?
Um
Dollars.
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 So this one is for 1%, and this one for dollars. Yes.
Yeah. Make sure all the measurement units. That's all. That's all. Okay. Holding parents variable as a constant, right? I know that usually, it's easily to forget, but you have to make it as a habit, okay? Especially for multiple regressions. And nowadays, you won't just work with single X variable only. usually is multiple regression instead of simple regression. Okay? All right? Understand what I'm saying here? Let's see the, okay, now if I want to save the output, okay, I can hit the name it, then equation 1, I can hit the OK. Therefore, if I close this up, then I go back to our original, this variable list, then I do have the equation 1. Did you see that? Then you can hit it, then open it. Then that's your result, regression result. Okay? All right. Then let's see all these variables first, right? Okay. Let's see. I can also highlight all the variable, maybe same sequence of. I highlight, okay. Then I can open it as a group. Then I can see the original data. Look at this original data. High school rank is using the measurement unit is percentage. This is from 0 to 100. So you can consider 90 is a 90%, right? Right? Okay. And how about the parents? This is using dollars. Okay. So let's see. Now I like to change from parents measurement units from dollars to $1,000. So let's try. Okay. So I will have a new variable. Oh, maybe I call it parent 1. And I change from the original dollars to $1,000. So what should I do? So you can see what I do, okay? Let me go back to, let me see. Quick. Is this one? No, it's not this one. How do I get another variable? Okay, just a second, okay? Let me see. I like to overview. Where the no, delete, no. Okay, why? How do I create a new variables? Okay, where do I get it from? Let's have my original. I'll save it. Okay, save us. Okay, let me save it in the new financial. Okay, let me save it. Okay. And this is financial aid, okay? This function here, okay? Did you see the generate? The last, second last function, GENR, did you see that? Okay, hit this one, okay? Then enter an equation. You can give make it as a parent 1. Okay, I'm sorry, parent. The other new variable called parent 1, which is equal to the original parents, ARENT. I want to make it from dollars to $1,000. So I divide it by 1,000, right? So I make it to a new variable, okay, which using the original one and divided by 1,000 and make it a new variable called parent 1. So I change the original parents measurement unit from dollars to $1,000. You see what is what I want to do? Okay, so then I hit OK. Did you see the parent one is here? Okay, then you'll see the parent one. If you go back to see the original data, this parent one, actually is make it as in $1,000 as a measurement units. Okay, all right, and you can run the works again, replace the parent to parent one, and see the coefficient. How does the coefficient change? Okay, all right, let's just stop here for a while, and we'll come back. We'll have a 10 minutes break.